Okay, so we are going to talk about quadratic systems of equations. And we've already learned linear systems of equations. What are the two ways that we can solve that algebraically?
Factoring or in linear form?
No, like solving two linear equations, like when they intersect. There's two methods. One starts with an E and one starts with an S. Substitution and elimination. Yes. So the same goes for quadratic systems. And we're only going to look at the first three. We won't look at 3 and 4 solutions until second semester. So you could either have 0 solutions where they don't intersect. You could have one solution. Maybe it's like a line and a parabola where they intersect one time. Or you could have 2 solutions where they intersect twice. And all of these pictures are showing a line and a parabola. So you'll either have like a linear equation and a parabola, or you would have 2 parabolas. And we'll look at both of them. The easiest way to solve from here on out is going to be through substitution. So basically what we want to do is get both equations equal to y, and EQ is just equations. And then from there, we want to set them equal to each other, and then we want to solve. That's not how you spell solve. Then you want to solve for x. Then plug in for y. Your answer should be in ordered pairs because they will now intersect at an x comma y value. So when you're solving a quadratic, you get x equals something. And then you're going to plug that into one of the equations and get a y value. So let's look at the example. One of them is already in a y equals format. And just by looking at it, would this be a parabola or a line? Parabola. So you don't have to label them, but sometimes it helps for me to just look at the equation just to kind of get a mental picture of what it's going to look like. And then the second one, would that be a line or a parabola? A line, because it's just an x, not an x squared. So if I were to set this equal to y, what would that look like? Y equals what? 2x minus 2. Good. You move the y over, move the 2 over. From there, I can now set 2x minus 2 equal to x squared minus x minus 6 because they're both equal to y. So I'm going to write x squared minus x minus 6 equals 2x minus 2. Now, to solve this, I want to move everything to one side, and I'm probably going to factor all of these are most likely going to be factorable. So move everything to one side, and then try to factor it. So when you move everything over, you get x squared minus 3x minus 4. That factors to be x minus 4x plus 1. And solving that would mean that x equals 4 and x equals negative 1. Now here's your review, David. If I were to graph this, what would I do? If I were to graph this, because it's in factored form, right? Just going to put my little graph over here.
You would set it to 0 to find the negative 4.
So my zeros would be where?
4 and negative 1.
4 and negative 1. Then how could I find my axis of symmetry from this?
You do this maneuver right here.
Okay, this maneuver. So what's the midpoint between 4 and negative 1? It's not even, so 1.5. And if my x is 1.5, or 3/2, how could I find my y? Plug it back in. So 1.5 minus 4 is
Negative
2.5, or negative 2.5, sorry. And what is 1.5 plus 1? 2.5. And when you multiply them together, I don't know what you get. It is a lot of work.
Don't worry, folks. I'm going to solve this bad boy.
Negative 4.25.
Yep.
Give me a go. And then you would draw a picture. So there's your review, David. You're welcome.
Right, now, please
Now we're gonna
it
move-
will be that simple.
Now we're going to move on. It is that simple. There's really no way to make it more difficult than that. Okay.
True or false have a way of doing that.
The y value of your vertex.
How low it goes?
Okay, now I have x equals 4, x equals negative 1. I've solved for the x's. What is the next step that I wrote out to the side? I need to do what? Plug in for y. It does not matter which equation you plug in for y because they're going to be the same. So I'm going to choose the easier one, in my opinion. Out of a parabola and a line, which one's easier? A line, exactly. So I'm going to say y equals 2 times 4 minus 2. So 8 minus 2 is 6. So I have the ordered pair 4, 6. And then y equals 2 times negative 1. So negative 2 minus 2 is negative 4. So I have negative 1, negative 4. And those are my two solutions. Now, if you wanted to check your answer on the calculator, you could graph both of these as two separate equations, like y1, y2, or function 1, function 2, and then you could find the intersection between the two.
Okay, if we had one solution, would one of our x values be, like, what would happen?
If you had one solution, I don't know if we have an example like that, but if we had just one solution, then it would look like when I factored it, it would look like x minus 4, like they would be the same thing, x minus 4, x minus 4. So you would get the same thing when you factored it. So then you would only have one solution.
So it would have to be a perfect square?
Yes.
Okay, great.
So it would have to be a perfect square. All right, let's look at the next example. Where are you? There you are. Okay, we have the top equation is already set equal to y, and it's a parabola or a line. Parabola. Second one would be a line. So y equals what?
Y equals 3x plus
3x plus 1. Good. What's my next step? Set these two equal to each other. So x squared plus 3 equals 3x plus 1. Okay, I want you to move everything to one side, factor, and solve. Your answer should be 2 ordered pairs. You can work with your group. So, because I want you to know how to do it algebraically, but this is what it looks like graphically, okay? So, here's my line. This is the 3x plus 1, and then this is my parabola. And we want to find where they intersect. So, if you can kind of see, and maybe I should zoom a little bit more, but you can kind of see how, I'm just going to...
No, that's fine. Or you mean...
I'm going to go, let's see. I need to change my x, min, and max. So let's make it 0 to, what's my, I'll just keep 0 to 5. There we go. Can y'all see that now? Okay, and then I want to see where they intersect. So
Works better
1,
than
4, and 2, 7. There they are.
All the calculators so it looks like so it would cover up each other.
Yeah.
It looks like an essay. Okay.
So it's just where they intersect.
Scroll past the word.
So you can always check your answer in the calculator, but yes, you have so lovingly pointed out that I don't always give you your calculator.
Well, I just.
Yes. In love.
So whenever we did the two multiples, is it just the two multiples that add up to be the C value? Like -2 times -1 equals 2, which is the C value?
So,
Because is this trial and error factoring?
yes.
Okay, so then how come whenever I do it, it's not the same thing?
Because you're setting the two equations equal to each other. So you're now involving two equations.
Right, but what I'm saying is like whenever I had x squared minus 3x plus 2, and then I did x minus 2 and x minus 1, whenever I factor those back
You won't
together-
you won't get back to one of the original equations. You're getting back to the two equations combined.
That's what I'm saying.
Mm-hmm.
It's like,
So maybe let's just try another example, and then maybe it'll make more sense. And then maybe you can go back and fix that error from the last one. So they're now both in y equals, so I don't have to move anything. I can just set them both equal to each other, right? So I'm going to say x squared minus 4 equals -3. Move the 3 over, so x squared minus 1 equals 0. And we love factoring these, right? What is it?
It's the plus and minus one. I
Difference of
practiced that a
squares.
lot.
Yep, difference of squares, good. So x equals -1 and x equals 1.
You wouldn't count off if we just put x equals plus or minus 1.
But I want two ordered pairs. So I'm going to have -1 something and 1 something. What kind of line is this? Just y equals -3.
it's a vertical line, horizontal line.
It's a horizontal line. So if I had my graph, it would be here at -3. So, and then x squared minus 4 is going to look like a y-intercept at -4, and it's going to move up, right? It's going to point upward. So, both of my y values would be what? -3. Good.
So just because it says y equals negative.
Mm-hmm. So from here, remember we're always, the first step in factoring, no matter what, is always to do what? Pull out a common factor. Well, they both have something in common. X. So I'm left with x plus 1. Can I do anything else? No. But I do have two solutions, and what are they? 0 and -1. Good, because I set this equal to 0 and this equal to 0. Now I can go and plug those back in, and I get 0, 2 and -1, 0. Good.
So when I did this the first time, I did x squared plus x plus 1 because I thought, but then I got the same answer at the end.
X squared plus x plus 1.
But I got 0, 2 and -1, 0.
But if you had plus 1 at the end, then that wouldn't factor to look like this.
Well, no, it wouldn't factor look like that, but it would make the same answer.
No, because you couldn't factor this. You'd have to use the quadratic formula.
But no, I didn't. Well, I don't know what I did, but I got the right answer.
That was a lucky guess.
I don't know.
Because these 2's will cancel each other out. Like when you move the 2 over,
Yeah.
it's like -2, and so then they 0 out.
I don't know what I did.
Okay, try number 4. All right, are there any questions about number 4? No? Okay, let's move on to number 5. What's something different about number 5 that you notice?
It's x squared on both sides.
It's x squared on both of them, so I've got 2 parabolas. Interesting.
Is that How many solutions?
It still can only be 2 solutions at the most. We haven't learned anything with 3 and 4 yet. We'll do that next semester. You're not mature enough yet. You just gotta work up to
Brain
it.
is still mature, still growing.
But we'll talk about the day when you're mature enough and you will have entered into
Been dreaming.
math maturity.
Oh,
What kind of form does it look like these are both in? A little review here.
That graphing thing.
Not factored.
The graphing thingy.
The one we learned last chapter.
Oh, the
Vertex form. Thank you, Tommy. Showing up today. Doing things. Proud of you. It's in vertex form. Little review. How would you graph vertex form?
Please don't tell me there was a true or false in this quiz.
So
Miss, no, you don't understand.
How would you graph something like this?
The negative depends.
it goes
like,
right.
tells
It
you
goes
if it
right
up
to
or
the
down.
1, right 1,
Right 1,
down 2,
down 2,
and then up 2 over 1, up 2 over 1.
and then up 2 over 1, up 2 over 1. Just a little review.
The other one is to the left, to the right 3, down 1, up 1 and 1.
Yeah, I'm gonna tell you to calm down.
So the other one is right 3, you said? 1, 2, 3. And then down 1.
Up 1 over.
Nice. So we can already see one intersection, right?
Show a quick drawing.
The negative trinity.
What point is this?
Do this the best.
It's kind of a poor drawing, but
Easier to draw these ones out. Or?
it's 2, 0. But I'm going to give you a little hint. It's going to go all the way up here because this slope is skinnier, this orange one. So there's going to be another one that we need to find algebraically. And it's going to be somewhere like up here. So now they're both set equal to y because I did it right here and here. So let's now set them equal to each other. I'm going to erase my picture if that's okay. Because I did the review for you, David. Don't. How would I go about doing this? How could I get everything to one side?
I know you have to subtract the parentheses, but I don't.
How could I make this look more normal?
Could you divide everything? Could you divide?
Yeah, I could. I could FOIL it out.
Oh.
So let's FOIL these out first. And remember that we don't just distribute the 2 or the squared because that's killing puppies. Remember how many of you did that on the test?
Seriously, what is wrong with you guys? I don't even know.
Remember how many puppies we killed? Thousands of them.
It's like a puppy mill.
So it would be 2. It's like writing x minus 1 and it's like writing x minus 3 and then you're FOILing it out. FOILing it out. Yeah, maybe we need to make a song.
No.
FOILing it out. FOILing it
You know
out.
what we could do? We could review for our quiz.
Oh, we have been.
The true or false.
I'm
is
just
gonna come from
I'm just
behind.
integrating it.
False. Yes, it's gonna come from behind and just bop me on the head.
Okay, what do I do with this 2 now?
What in the?
Wait.
Wait, hold on.
See, that's where I got the 1 from. When we do this, and it equals 0, it's the 1. Because
All I did was FOIL it out. And I left the 2 in front. I don't use that 2 until the end.
Let's just leave it there.
No, we don't want to leave it there. Now I want to distribute at the end, Tommy. At the end.
But it's ready now.
It's ready now, but it wasn't ready before. It wasn't ready to insert itself into the first parentheses. But now it's ready to go.
So we can.
So now I can do this.
Wait, what?
That looks great.
No, she.
So do you see my blue boxes, the foils? I do that first.
Well, it's plus 2 minus.
Then,
No, I know that, but like you made it sound like you weren't gonna distribute.
oh, but I am.
Yeah.
I just did it. It happened.
Can you just put plus 0?
I could. I'm just gonna cross this out. I had a college professor that would say, I'm just gonna Hershey bar this out. Because he never had an eraser, he just used Sharpie for all of his notes. He was like, I'm just gonna Hershey bar it out.
What's the lowest grade you've ever gotten in class?
Maybe 3.
I don't know. Okay, from here, move everything over. So x squared, then what? What? Plus 2x minus 8 equals 0.
Wait, my brain's not there yet.
Okay, take a second to digest it all.
What were we saying, David? What were we saying?
How do I factor this?
You would do
Oh, I see what I did wrong. I got it.
X plus 4,
x minus 2.
x minus 2. So x equals negative 4, and x equals 2.
Oh, where's mine?
So negative 4 comma something and 2 comma something. I'm going to give you a second to plug those in to one of the equations, doesn't matter which one, and find it because you're going to get a big old number for one of them.
Oh, okay, good.
Okay, any questions about this?